Welcome to solverfy.
All right, here we're told that the jerk is defined as the time rate of change of the acceleration is constant. So we're told that this quantity is a constant. And we want to compute the acceleration as a function of time, the velocity, and the position. From this initial equation, which is a differential equation, we know that the acceleration then is going to be equal to the jerk times the time plus the initial acceleration. So this is the acceleration as a function of time. Then this is answer A. The velocity is equal to the derivative of the acceleration. No, sorry, my apologies. The acceleration, remember that it is the derivative of the velocity as a function of time. So if we integrate using calculus this equation on the right side, we get that the velocity is equal to the initial velocity plus 1/2 the jerk times square plus the initial acceleration times the time. And since we know that the velocity is the derivative of the position as a function of time, which is what I wrote up above, and we integrate this as a function of time, we integrate this with respect to time, we get that the position is the initial position plus the initial velocity times the time plus the jerk over 6 t cubed plus the initial acceleration t squared over 2. And now we want to compute the change in acceleration times the change in velocity times the jerk. We want to prove that. From the first equation, knowing that the jerk is constant, we can compute the time as follows. We know two things. We know that the time is equal to the change in accelerations divided by the jerk, because from the differential equation above, the solution to this one. And then, now that we have that, we can use this equation and this one to compute the equation that they want us to compute. So we use change in velocity is equal to the jerk over 2 times this quantity square, initial over 2 over the jerk square, plus the initial acceleration times the time, which is nothing but the difference in velocity or in accelerations divided by the jerk. It's the difference in accelerations over the jerk. We put this over here. If we expand this these polynomials, we will get and multiply across by twice the jerk. So twice the jerk times the change in velocity in one dimension is equal to ax minus ax initial square plus 2 ax initial ax minus 2 ax initial square. If you expand the square difference, you will get with the result of ax square minus ax initial square, which is the answer that we're after.